Welcome to lesson 5.5. The objective is we're going to solve quadratic equations. So all that factoring practice is one of the ways we're going to use to solve. The other two, well, finding square roots is one. That's actually the first one we're going to look at in examples, and then by graphing them. So using a graphing calculator or a graphing website. And I'll show you all about that as well. So we have three different ways that we're going to solve, and it's going to be based on what type of equation you have, which is like which way you're going to pick to do it. So again, the first way is we're going to look at how to solve by taking square roots. Notice how there is no linear term. It's just a quadratic term, so there's no linear term in between. It's just a quadratic term and a linear term. When that's the case, you can solve by taking square roots. You're going to solve it just like you would a linear equation, meaning you're just trying to isolate the x. So we're going to do inverse operations to get rid of everything else except the x. So the first one we're going to do is add the 486 to undo the subtracting. So now you've got 6x squared is equal to 486. That 6 is multiplying, inverse would be dividing. So now you get x squared is equal to 81. Inverse of the exponent of 2, so that's squaring, right? The inverse of squaring is square rooting. So we're going to take a square root of both sides. And x is equal to 9 and negative 9. You can also write that with the symbol All right, you can also write that with the symbol x is equal to plus or minus 9. Okay. Let's take a look at another example. We're going to add 50 to both sides. We're going to divide both sides by 4. We're going to get x squared is equal to 50/4. I'm going to simplify that fraction and make it 25. Actually, you know what? It's actually going to be easier if I don't simplify that fraction, oddly enough. We're going to take a square root of both sides. And I end up with x is equal to plus or minus square root of 50. And it's plus or minus because when you take a square root, it's both positive and negative, right? Square root of 50 over square root of 4, which is just 2. So now I can just say x is equal to, I'm going to simplify square root of 50. Remember how to simplify a radical, right? You look for a square factor, you get 25, and you get 2. 25 is a square number. Square root of 25 is 5. And then that 2 has to stay. So plus or minus 5 square root 2 over 2. Same thing with this one. Only thing I need to do to isolate, only thing I need to do to isolate the x squared is divide by 3. So now you get x squared is equal to 8. Then when you take a square root of both sides, you're going to get x is equal to plus or minus 8. You can break into 4 and 2, right? Where 4 is a square number, 2 is not. So you get 2 root 2. So looking at this strategy in context, that function models the height y feet of a heavy object x seconds after it's dropped from the top of a building that is 270 feet tall. How long does it take the object to hit the ground? Well, if y is the height, we're going to substitute 0 in for y. And now I'm just trying to solve for the x squared again. So I'm actually going to add this to the other side. You get 16x squared equal to 270. We'll divide both sides by 16. And you get x squared is equal to 270 divided by 16. take a square root of both sides, and you're going to get x is equal to square root of 270 over square root of 16. Square root of 270, 270 can break into 27 and 10. And actually, that's not the way you do it, because 27 is not a square number. It's a cube number. Hold on. I guess we'll split it into 9 and 30. So that'll end up being 3 square root 30 over, and then square root of 16 is 4. And it would be plus or minus. So again, since it's the answer to this question is actually a time, you're not going to say, oh, it would take 3 times square root of 30 divided by 4. So we're going to estimate that as a decimal. And you're going to get 4.10 or that 28. So that's how many seconds, a little over 4 seconds, it would take for that object to hit the ground.